What is an IonoCopter?
So an IonoCopter, I initially came up with the name because I was trying to combine the word ion, because that's what spit off in this type of discharge that I was using. I'll go into that in a second, but I tried to combine the word ion and then like a quadcopter because that was the design that I wanted to integrate it on. So IonoCopter came out of that, but what it is pretty much is an idea, a prototype for a drone specifically for stealth applications, that has no moving parts. It involves the utilization of a type of plasma discharge called a corona discharge. And in the process, what happens is you're putting a electrical current through a circular, like positive of electrical piece. I always say something like it can be pretty much anything. You can like spray out a wire. You can spray out uh, just a random piece of metal, a tube. And you can get this kind of discharge as long as there's a distance that you're ionizing air between and another negative end that's connected to the same circuit. And so when you apply that to a circular pattern, you get this type of circular discharge that traps air in the inside of the circle, and that air is battered with ions from this ionizing process. It can be battered with like the electrons that come off of that. And in the process, those molecules get basically shot out the other end. As long as you have a hole where that negative piece is, you can channel that directionalized air and you can get thrust. And so that's where the whole idea came from. And that's where I guess the word IonoCopter comes from.
That's cool. Is it a similar process to, do they call it a Jacob's ladder, where you have two pieces of wire going like this? And
Yeah,
is it similar to that, but reconfigured?
yeah, a little bit. Yeah, it's a different like topological orientation because instead of having, the air that's being ionized across the way like this, across the entire ladder length, you're having it at a constant level of discharge on a circular pattern. So
That's cool.
yeah.
Now, you just won a bit of money with this concept. Can you explain how you won this money and where that got started?
Sure. So I initially had this project running on like the back burner or something that I would just do in my free time at college. Because, I mean, the classes are kind of dry, not to be like, crapping on the college, but
Amen.
yeah, the classes are kind of dry. And so like I was looking for something to do in my free time and I was like, oh, I'll just do this project. But my roommate was working at this place called the CIE, the Center for Innovation and Entrepreneurship. It's like one of the departments on campus. And they were putting together this competition for entrepreneurs. And he's like, you should apply with this idea that you've been like working on. I'm like, yeah, that's a good point. And then it gave me kind of this deadline to like actually work towards. But yeah, and I continued working at that. And by some miracle, the judges liked my thing. And then so with that money, I'm probably looking forward to reinvesting it. We spoke a little bit before the recording about investing into like a bamboo printer because I'm trying to move away from the campus's makerspace because there's a lot of time constraints and people constraints over there because sometimes it's not staffed all the way. But yeah, hopefully I can move towards that. I've just recently purchased with part of that money the bamboo printer, so hopefully I can start doing a little bit more precise prints, get that anode and cathode relationship right, because that's what I'm doing moving forward is a lot more R&D work between the distance between the anode and the cathode, the shape, the amount of teeth that I can add on the positive end, the whole, yeah.
Which printer did you go with from Bamboo?
I went with the X1 Carbon just because,
Nice.
I saw the Black Friday deal and I was like, all right, I have to do this.
What was the
so
Black
good.
Friday deal? I didn't see it.
It was like $200, $300 off. And at the same time, I was like, all right, if I'm going to buy this whole thing, I better get it right. I better like get the whole package. And then as much as it like may amaze you, I am not a 3D printing wizard. I'm not like, I'm an engineering student and I kind of got into the world of 3D printing late. That makes any sense. A lot of the stuff I've learned from 3D printing, I've learned from YouTube or I've learned from, other people. So yeah, that's pretty much it.
Did you get the AMS with it?
I did get the AMS with it. Yeah.
Dude, that's awesome. That's cool.
Yeah. I love the AMS.
I did a project this weekend. Somebody asked me to work on some things and I had all this extra black laying around, like little spools of black left over. So I just loaded my AMS with all these partial spools of black and then just hit go and used up all my extra filament, which is pretty cool. But what a great platform. Someone told me the other day, using a bamboo printer is like using an Apple product. Like it just works. And so there's like a love-hate in the community with it. But I really am satisfied with the platform and the equipment. It works really well. With these parts you're printing, are you then doing some sort of metal plating with it?
That's right. Yeah. So, I mean, right off the bat, I'm a college student. I don't have the funds available to do like silver plating. So copper sulfide is probably like the most available electroplating solution out there. It's very cheap, and I think they use it for like a fertilizer or something. And it's what's recommended on a lot of like YouTube channels for electroplating. It's like, just buy this on Amazon. And I set up my own rig for electroplating. But yeah, what I tend to do is I tend to carbon coat these very precise prints, because like I needed to use precise printers like the bamboo, because for the anodes, your whole thing is you're trying to maximize the amount of area that's contributing to the circular factor while trying to also reduce the total mass, right? So you're trying to work with an extremely light filament that is capable of producing like, very fine things. Because again, when you're producing that electrical discharge, it's better to have it off of a sharp point on the positive end and a rounded point on the negative end. It just, for some reason, there's some kind of electrical continuity there that makes it the discharge, the critical voltage required for the discharge less. So rounded edges, especially when you're talking about something that's like a toroidal shape, for bamboo is, I think, probably the best printer for that. Just like, standard that you'd find everywhere that's not like souped up to the max. I wouldn't have access to those, but yeah, I think they're just the best printer for those. But yeah, to go back to the electroplating process, what I tend to do is I tend to take those very precise prints, I carbon coat them, and then I electroplate them in copper to make them conductive.
Are you telling me you were electroplating in your college dorm room?
Maybe.
That reminds me of my freshman year. I had a Creality CR10 set up in my dorm room, and I would run it all night long. And so I had earplugs that I would put in and go to sleep. And it even had like a thing that covered my face because it lit up the room with a big bright blue screen. But like the people beside me and above me could hear my printer running all night long. And they're like, dude, what's going on in your room? It's like, oh, I was 3D printing something last night. Those are good memories. But with the makerspace on campus, what is that like? Do you have an online queue to submit your parts, and then there's students running it to print it off for you? You actually don't get to print it yourself?
Yeah. What tends to happen is you send the STL file, and they're the ones that throw it in processing, G-code. And don't get me wrong, they're good at it. They know what they're doing. The issue is, like I said before, the staffing. A lot of times they don't know who's working when. And so you'll walk in and be like, I need this printed. And that's, by the way, the only way that they'll print it for you. Not to like, crap talk on them, like I said before, but like that's the only way they'll print it for you is if you walk in. If you try to do the whole online form submission thing, they push you way to the back of the queue. So you have to like show up and be like, hey, can I get this now, please? But besides that, I mean, I can't complain on it because it's a free resource. But on the other side, it's just not the standard that I need for, an actual company.
Yeah, it's a great resource for anyone that's trying to get into 3D printing or to create a prototype off the bat, dip their toes. But whenever you're in a phase in which you're rapidly prototyping and making different iterations, it's not ideal. Like this weekend, I was trying to 3D print some pulleys that would go over a metal bearing. And it took me like 5 attempts to get the tolerances right so it fit well. If you try to do that through this makerspace with a queue, it would take you, 5 weeks to make that pulley versus, a couple hours.
Exactly.
So I feel your pain there. Andrew, so you're a student at Embry-Riddle University. Which campus are you located at?
I'm at the Daytona Beach campus.
Okay,
in Florida.
Cool. Do you go watch some SpaceX launches down
all
there?
the time, dude?
Yeah,
all the time, and we can actually see them from campus. That's the beautiful thing. Like, as they're coming up with the horizon, so you can't see them like off the launch pad or whatever, but you can see them come off the horizon. You can actually get like a telescope out and follow it. A lot of guys use binoculars, like the really souped up ones, but you can actually see the rocket as it's going. I'm like, it's beautiful. aerospace engineering student, so like that's my whole gig. I'm more in the satellite kind of thing, side of things. But yeah, it's so cool, so cool, and it's just like a reminder of what I don't know human beings are capable of, and you kind of just like as you're looking up, you're like that's greatness,
It is. It's absolute greatness. And I love aerospace engineering, especially in rocketry, because it is incredibly dangerous. And there's so many things that can go wrong. So many things that can go wrong. And like you end up with an explosion if that happens. So it requires a crazy amount of human collaboration, like working at all levels. Like you have to communicate very clearly. And so I think it's one of the most beautiful demonstrations of like a group effort.
Yeah.
Because the risk is so high. And I think aerospace engineering is really cool because it brings people from a lot of different backgrounds together. And like, especially like operating in the ISS, like it's so cool to see people from different countries. It's like, we're all on the same team. We're all human here. I find that to be beautiful. And so it is really cool how that all works. And that's cool that you get to watch that at college. Like you're studying engineering and, like that's your future right there, flying up into the sky with that, whatever organization, end up in. That's a great like reminder, like why you're sitting in those boring classes.
Yes.
I've never,
yes.
I've never seen a rocket launch in real life. I really want to someday, but I've never seen it. No. I've yet to see one.
Yeah, you should come down to Florida sometime, man. Like we have them, guys, every day. It's amazing.
Yeah. Well, I'm going down twice. I guess in February. February, I'll be going down in either end of February, beginning of March. I'll be down there. So, I really want to get up to Daytona and see a launch. That'd be really cool. Oh. Do you ever go and watch them land?
Oh yeah, like I saw once one of them land. It was just, I mean, you can't put it in words because it's staggering. Because I'll be struggling to make gears fit together, and you're kind of like, what is this, dude? Like, it's amazing.
You just launched this rocket, or you just landed it, and I can't make these gears to go together.
Yeah,
that's
right.
Funny. Teamwork.
We had a story from one of our professors that he was eating lunch like by the right where they had the what do you call that thing that goes out to go catch the rockets, the one that the boat that floats out, and they had like a front row seat right outside the restaurant to watch this thing land, and it was just like, that's amazing.
That's cool. Doesn't it say something like you're still loved or just follow the instructions on it?
Yeah,
something like that. So did you start your freshman at Embry-Riddle, correct?
Yeah, I'm a freshman.
Yep. Did you start the IonoCopter project before getting to college?
So I had an idea of what I wanted to do coming to college. So it was actually kind of hit me when I was moving in. I was like, I guess I could do this. And then really the whole idea came about, really solidified when first I heard about the project. And second, I was working, I work part-time in our university's plasma lab.
That's cool.
It's part of the Satellite Atmospheric Instrumentation Lab. I think it's what the full name is called, but there's an engineering physics section and they work on the plasma chamber. And I was reading about a story from the Israel-Hamas war about them using drones to try to follow Yahya Sinwar, who's the military commander of Hamas, into a building, and that the drone was so loud that he was able to throw a stick at it and partially disable it. And without their forward, looking reconnaissance piece, that drone, since it was disabled, they didn't want to risk sending people inside the building. So they send a tank round into the building and kill everybody inside, which, mission failure. You're not capturing this military commander. And so as I was reading the story, I was like, is there a way to make drones quieter and then also cheap? Because there's a huge arbitrageable imbalance with, especially in the US drone industry, about expensive drones. And also silent technology is very expensive as well, right? Where you're talking about, would you rather have something that's loud, something that's expensive and quiet? Well, why not have cheap and the quiet? I don't know. And so I felt like the answer was staring me in the face at the time. I was like kind of staring off into distance at the plasma chamber, and I'm like, oh, why not just have this kind of discharge? And so I started reading a lot about different types of discharges. And then I finally landed on a design that was more akin to like a jet engine with the whole curvature. And I did a lot of research on YouTube about, is this idea already around? Does it already exist? And I found a lot of like the MIT paper about discharges, specifically about kind of using discharges as a way of lift. There's a lot of experimental planes that they did, like lightweight planes. But no one had really done a quadcopter design before. And I was like, oh, I mean, I guess I can try this. And what's the worst I can do? At least we'll know that it doesn't work, So that's where this all came from.
That's cool. Now, right now you're just working on the propulsion system, right? You haven't developed a copter yet.
So as you scale the size of the propulsion system, it's a lot easier to kind of design the copter, because the copter is just where the propulsion systems are going to sit, especially if it's a quadcopter design, where the propulsion systems are going to sit. And then the interpolated distance between the two, right? Just like arms and then a body and like where the battery is going to sit. So, I mean, the drone itself is not the difficult part. The difficult part is the actual propulsion system and then making that lightweight. But I'm telling you, like, the best feeling in the world is I had like a small mock-up, right, of the drone design. And I was testing voltage ranges, and the top piece of it was starting to like jump. And I'm like, oh my God, this can actually work. This can actually work. And when you have like that, this can actually work moment, it's so like euphoric. I really can't compare it to anything else.
Yeah. You succeeded. The amount of dopamine that is immediately released.
Yeah.
That's cool. It's like when you make that tolerance finally work, or, you write that one line of code and it makes it execute properly. That's exciting. Yeah. So right now, based on the design that I saw that you had with the poster, it's a 4 ion system. Do you think it'll stay that way, or could it potentially go to like 8 thrusters?
It might depend on the strength of each thruster. So far, I've gotten like marginal returns based off of changing voltage range, but because of the way of discharges work, there's a minimum and a maximum. At a certain point, at the maximum point, you start getting slight imperfections in the copper plating will cause the discharge to try to follow the path of least resistance, and it'll just go into one solid beam and start zapping, right? And it kind of scares you because you're like slowly tilting it up, and it goes. You're like, oh, you freak back a little bit. But then even on the minimum range, you need a minimum critical voltage in order for the actual discharge to occur. So, I mean, there's a range there, and the more you play with the range, you get marginal returns. Like, actually, the more voltage you push through, kind of like you kind of predict it, right? Because look at the relationship between electric fields. The more voltage you push through this grid of the electric field, you're going to get more airflow. So right now, that's what I'm doing. I actually have it running right now. I have several different iterations of size. So I'm going to look at try to plot the relationship between the two. Try to see if there's like any actual observable difference between like radial distance, like size wise, and then the outputted air versus the like critical voltage.
That's really cool. So then through this process, you can figure out what's going to be the optimal size and voltage for what you're looking to do.
Exactly.
Fascinating. Now, when you said like sometimes it'll then channel in and just make one arc instead of the full discharge, it made me wonder, have you shocked yourself at all in this process?
It's the other thing too, is you learn to stop being afraid of electricity a little bit. Like
famous last words.
I'm very, yeah. I mean, don't get me wrong. I'm extremely safe with this thing. I really don't want to like have people walk into my door and be like, Andrew, you okay? And just like slumped over, But I have shocked myself a couple of times, and I think it's just a nature of like the low current, because I'm using a huge step up converter, like 4.2 to like 400,000 volt step up converter. It's crazy. But like the low current on that, I don't think it's gonna really kill me. But yeah, it does hurt a little bit,
Little zap. Is that a step up converter you got from the Plasma Lab?
No, I bought that myself.
You got your own.
A lot of the step up converters have this huge problem, is that they're covered in I don't want to say asphalt, I forget what it is, epoxy resin. And it's extremely heavy. And I think it's just like a shipping regulation thing. So I'm probably going to have to custom make my own with different types of transformers.
Yeah, I did a project like a year ago, and I got a step-up converter. Like it was just a like black enclosure with epoxy on both ends, and then wires coming out. And I 3D printed a Venturi system, and then modeled it to look like a rocket engine, and then mounted the step-up converter to it, and then hooked it up to an air compressor, and put like lighter diesel fuel in the chamber, and turned it on, and it started shooting flames. It was so cool.
Wow.
And so then I put it in a pumpkin for Halloween. And so the idea was when people walk by.
That is so cool.
Yeah. When people walk by, I had a motion sensor, and it would then automatically turn on this flamethrower and start shooting flames out of a pumpkin. So I tested it in the backyard and walked by it, and it started shooting flames, but then it wouldn't turn off. It just kept going. So it kept going. And the pumpkin like melted, and there was fuel everywhere. It was really cool. Yeah, that was a fun project. Don't recommend doing that, but I was impressed that the PLA held up from that.
That is
have you considered? Yeah,
PLA held up? What?
Yeah, I did it with PLA, and then I used like a soldering stand just to hold the terminals to like the igniter, and then start going, but start shocking across there.
Oh my god,
that was a lot of fun. That put a big smile on my face when I did that the first time. I was so excited. I couldn't believe it worked. So I mean, the flame was like, I don't know, 5-10 feet long. I don't know that it created any thrust, but it was a huge flame. It was so cool.
Damn.
Yeah, that was one of those projects I like threw away once I was done with it. Like, I don't want this occurring again. It was fun. Now I'm wondering, with this IonoCopter and making, what do you call it? Do you call it a thruster? What do you call the thruster? Have you thought about doing it with a resin printer?
So
I'm sure you have.
I have. The only issue is like, so I watched your video and I actually ran into the same freaking problems, which is that they're brittle. And on top of that, not on top of the fact that they're brittle, but when you're trying to when I was trying to put this thing into my little mock-up like stand, it kept breaking. And that was the frustrating thing, is that I would like cover it in carbon, I would electroplate it, and then it would break. And I'm like, but not just the outside, it would be like a chip or something. And then it would screw up the entire, because remember I told you before, you have to have that circular pattern. And if there's an offset in the circular pattern, it's not like, oh, the rest of the circle is going to complete. It now, there's a huge, like, lack of a better word, gaping hole in the side of this thing that's going to prevent the discharge from occurring correctly. And you're just going to have it be that one solid stream arc. And so, I mean, it was just incredibly frustrating. I think I did it twice and I'm like, this is done. And like I said before, I was relying on the makerspace. Our makerspace does have a resin printer, but it takes even longer than the regular prints because I think they only have like one, and they have like one resin curer too. And so it takes forever. The queue takes forever. So I'm like, I'm really done with this. So yeah.
Right now, all I can think about is all the people in the comments that were telling me I was stupid and didn't know how to use a resin printer. And the funny thing is, I see most of the comments because they pop up on my watch or my phone, and I love seeing it in real time. It's like, you don't know what you're doing. Get like ABS resin or something. Like I really don't know how to use resin printers. They frustrate me. I would like to get good at it. I think it's cool to make such a high quality product, but yeah, all I can think about is all the people like telling you and me right now, you don't know how to use a resin printer. Well, you're right. I should probably get better at it. But it's a mess. Like, it's an absolute headache to use one. I'm assuming you didn't have to deal with the mess, given that it was through Makerspace.
Right.
But every time I do it, like the cleanup time, it's frustrating where you just hop on an FDM printer and you rock and roll.
Right. Like, I think just the time of setup and like you said, like the time, that's what prevented me from I was having to decide when I had my prize money come in about like, do I want to go with bamboo or do I want to go with a resin printer? And I think the bamboo was probably a better choice just because the resin printers just took forever. And the reason why resin printers like came into a renaissance to begin with is because Prusa didn't actually like develop any of their product for like 7 years. And then bamboo came out of nowhere, shocked the whole game. and that's why bamboo's the best. So
Yeah.
I'm a bamboo fanboy. So
I am a big fan of bamboo as well. What filaments are you utilizing? Are you are you just using PLA, or are you looking at like other materials?
Our makerspace had a lot of different materials that I tested out. Right now, like right in the current iterations I have, I'm doing PLA carbon fiber. I'm also doing lightweight PLA from Polylite. The lightweight is not printing too well. I think I just have some printer settings wrong, but I think I'm gonna have to fix it a little bit more. Just like tweak it a little bit more. But what was the other thing I was working on? But my initial like first prototypes were in PETG, like black PETG, and what was the other one I used? Oh, our makerspace had access to a Markforged printer, the carbon fiber Markforged with the Onyx filament. Very, very cool. I can't like lie, but the problem is it's advertised to be lightweight, but on the scale that I'm doing, where it's very small, then the infill is already small because it's a thin thing. So it's just layers. You're just doing like outer wall layers. I mean, it was like I think it was like a 0.3 gram difference between the carbon fiber from the Onyx and the PETG. So I mean, it was not really measurable to the point where I'd be like, oh, I need a Markforged, whatever, like $3,000 printer, Yeah. So
maybe there's a line someone told me I like. Maybe in a later inning, maybe not this inning, but maybe a later one. But
yeah, exactly.
The other day I was looking on the Bamboo Lab store, and most of the filament I try to use is called atomic filament. I really like them. They're based in the United States. Prints great, but sometimes they don't have they have your standard printing filaments, but not really the unique stuff. And so I was looking on Bamboo Lab at their kind of more unique materials, and they have some different aerospace materials. I saw. Yeah. I'm looking at one right now. There's a ASA Aero, and there's a PLA Aero, which seems to just be a lower density, lighter weight material. That might be worth trying. It'd be cool.
Yeah. The only thing I'm worried about especially for PLA is just impact, like tensile strength, especially when you're dealing with like PLA oil will just shatter if you like throw it at the ground.
Right.
So I
really want to try printing nylon sometime. I was talking to someone the other day, said they're doing that. Yeah, that sounds awesome.
It does sound awesome, but also like I've like almost gassed myself one too many times with experimenting with different types of filament, especially like TPU and ABS. And I'm like, oh, but like anything that's doesn't have like PE in the front of it, I'm kind of like, stay away from it.
Stay away from it. Be like, I'm good with that. So this competition that you entered in, what do they call it? The Embry-Riddle's
the
TREP, the TREP Expo. What does TREP stand for? I couldn't find that.
So I think it was named after like a director of that CIE. But from what I understand, I think it's just like a thing that they came up with. I have no idea. They never really
couldn't find
yeah.
I couldn't find like a write out. Like this is what it stands for. Everywhere it just says TREP Expo. Yeah.
I mean, the full name is the TREP Entrepreneurship Expo, but I thought that TREP would split up into different things as well. It's not.
That's well, you won. You took first place. Yeah. I mean, how does that feel to be a freshman and come in and beat all the seniors and the juniors and the sophomores? That's an awesome feeling.
Well, it's crazy because the person that was next to me was my my lab TA. And he had like a group project with all of his senior friends. And it was nuts. It was nuts because I don't know. They told me that I was like the youngest person ever to win a TREP Expo because they've done this before. They've done it like a couple previous years of it. I don't know. It's like I said before, it's kind of like an ego boost, but it's also like maybe I can do this kind of thing.
And you did this by yourself, right?
Yep.
And you beat these other teams. Is it all undergrad, or is there some graduate students involved too?
So that chemistry TA that I was just talking about,
Yeah.
he's a master student. So yeah, so there's some master students around there as well.
Yeah.
Which it's crazy, absolutely crazy. And there's like real established companies there too. Like there's like a jet cleaning business that had already had like a couple $1,000s in profit, and they're getting themselves off the ground. No pun intended. But yeah, it's crazy. I mean, there's no other really words for it. I can't really describe to you how it felt, because this was like the first time in my life that really from start to finish, it had been just me. Like previously I had like, maybe my parents pushing me, maybe it was like friends, or maybe, like, coming together on a group project or something, but this was like just me. And I don't know. I think that's probably the closest like I've been to happiest in my ever life. It's crazy. Anyway,
Really? It's rewarding.
yeah.
It reminds me of whenever I was at Penn State. I did several similar competitions with Inside Entrepreneurship. And I was at this one competition where you get on stage and you actually pitch your invention, your company, kind of like Shark Tank style. And then there's a panel of people that ask you questions. And I remember sitting there in the audience, and this guy walks in, like, and he had this like chain on. And I was like, who's this guy I think he is? Like showing up to the entrepreneurship competition, trying to be really cool. And here I am, like a silly redneck engineer. And so I get up on stage, I like pitch my competition or my venture, and then they invite this guy on stage. I didn't realize it was the Penn State quarterback.
Holy smokes.
Like this, it's the starting string, first string quarterback. And here I am, like, yeah. So he pitches his venture, and then I ended up taking first place with my team, and he took second place. And it was like so cool that I just beat the Penn State quarterback in this entrepreneurship venture. That was a fun day. That was a good time. That's cool. So being that you're a freshman at Embry-Riddle, and that you just won this competition, you must have had some sort of different experiences leading up to college to prepare you for this. What kind of experiences or things did you do in high school to prepare you for engineering?
So, in high school, from like my freshman year of high school, I was really involved in robotics, specifically FTC robotics. And I mean, you can actually see I'm wearing this shirt right now. I have so much merch from that team. Anyway, yeah, I was really involved with them. And my junior year, I was like team captain, engineering lead, and then seeing the same thing my senior year as well. So, I mean, that's not too far out of the realm of, most people's experiences, but our robotics team got a lot of funding from the school. And so we kind of had like the newest toys. And, I mean, that's where I learned how to work a bamboo printer, was from them. We did laser cutting. But yeah, I had a lot of engineering experience from there, but also I was surrounded from a young age with a whole bunch of like very high achieving people. I tell people all the time, like, I would get like a 99 and my friends would get like 100. And they'd be like, Andrew, why'd you get a question wrong? What's wrong with you? I'd be like, oh, well, you're so right. What am I doing? But I think it's that when you're surrounded at a young age with people who want to strive for success, you have a tendency to also push yourself. Not just trying to chase those people, but also just because it feels right. It's kind of like an environmentally determinism thing. I don't know.
Well, you are the sum of the 6 people you spend the most time with. Isn't that the saying?
Right. Yeah.
I like to consider books can fall into that category too. I like to do a lot of reading.
I think the same thing, exact same thing. I spent a lot of time with books when I was younger. Like I had a very core group of friends, that kind of stuck with me throughout my life. And the books definitely were in the rotation for friends a lot more than people. But I actually, there's a book called Atlas Shrugged by Ayn Rand that completely changed my life. I read that book junior year, and I was going into my, oh, it was my summer between my sophomore and junior year. And I was going into my first internship at Aerospace. It's a company out in Merritt Island that they do satellite work. And I was doing that between my sophomore and junior year in high school. And I was reading that book during that time, and it completely like reframed my view towards life, like what it means to actually live. Like, what can I do to maximize my time in the real world? You know, because we all have like a set period of time here. But yeah,
I think about that just about every day. In fact, like yesterday, I was driving down the road, and I said, "I'm going to die someday. This is awesome." You know, it's like the scarcity provides a value, and you can keep in the mindset that one day you will not be here. Then that provides a lot of value to today and every day that you have here. And I think like people that are high achievers think about that a lot. You know, that you don't want to waste a single day you have here on this earth. And that's incredibly motivating. You know, some people don't want to have that conversation to talk about death. Like that's sad, negative, scary to them. But other people, it's like, well, that's incredibly motivating. It just depends on how you look at it. Now, I don't remember too many high schoolers doing aerospace engineering internships. Is that common? Is that common where you're from?
I went to school with a lot of children of like lawyers and doctors, and either they would get like medicine internships or like, you know, go to like Orlando Health, because I'm from Orlando, Florida, and they go to like Orlando Health, or the lawyers' kids would like volunteer at the politicians' offices, and you know, they get internships there. And so I kind of looked at in the frame of like, well, I knew from a very young age I love satellites, like more than most people love. Like people talk about dream cars, like I have like dream satellites that I want to build. And yeah, and so I knew what I wanted to do from a very young age, and I was kind of like, okay, so what can I do now, like all these people are doing, to you know, put myself in that direction, give myself a leg up. And the thing that I heard from the most people was that, hey, unless you have work experience, people are not going to give you internships in college. And I said, okay, how can I get work experience? And they're like, well, you have to have experience. I'm like, oh, well, that's kind of a huge issue, right? And so I was like, all right, I guess I should use this time now. And so I think I applied to like 60 or 70 internships my junior year.
60 or 70?
Yeah. Internships my junior year of high school. And I got one call back from this company, Aerospace. And they basically said in the interview, they're like, yeah, we saw that you applied to every single one of our positions we had open. I'm like, yep. And they're like, how do you feel about systems engineering? And I'm like, I can do that. And they're like, so what do you know about it? And I'm like, they basically gave me this like long list of stuff, and I got about half of the stuff on the list. And they're like, we can work with this. And so I was in, and when I got in there the first day, I felt like I had like a debt, because I was like, I looked around and it was like college sophomores, college seniors, college juniors. And I was like, I don't belong here. And so I would literally get there before everybody, like anybody of the workers would get there. And then I'd close out the building with HR. And I spent like 10, 11 hours a day there. Yeah. And I felt like, I had to give back for this opportunity that they're giving to me. And by giving like the most I can possibly give. And as a result, I got to be really, really close with the senior electrical engineer, who was running a lot of their satellite, like solar panel deployment mechanisms. So the entire satellite was shaped like an octagon, and every side of the octagon had a solar panel. And so me and him worked on a lot of like experimental designs for the solar panel deployment. And this is my favorite thing to tell people. I actually have flight hardware that's in space, technically, because the part of that solar panel deployment mechanism, it was on LizzieSat-1, which was their flagship satellite. And yeah, I'm, every day I pinch myself. But yeah.
That's awesome. Well done.
Thank you very much. I really appreciate that. Especially from someone who has like an amazing YouTube channel.
Oh, well, thank you. Thank you. That's fascinating. You literally brute forced yourself into an internship. That is awesome. And the fact that you applied to every single position, that's cool. Like that's a wonderful part about engineering. It's like it's working with people.
Yes.
And I found that most engineers are good people that want to make a positive impact on the world. And so that's cool that you got to build those relationships with those people. Is that an organization you see a future with? Do you want to go back there for another internship? Is that top secret information?
So I got brought back last year as well. But this year I was getting like from the grapevine that they might not have an internship program. But very recently, I think maybe something changed with their contracting, or they got more money, because I know they signed recently a deal with SpaceX and they just launched their second satellite. That it may be a possibility. If that's the case, I'm definitely open.
That's cool.
Just putting that out there.
Speaking of SpaceX, have you read or listened to the recent Elon Musk book by Walter Isaacson?
I have not, and that has been literally on my reading list. I think I'm going to get it for Christmas, because like I have been like telling my parents about this all the time. I'm like, have you heard about this? But
so I can't say that I read it because I listened to it on Audible, and it took me forever to listen to it. It's like 60 hours or something on Audible. It was something crazy.
Oh my God,
maybe 40. I don't know. It was really long, but I loved listening to that book, and a part of the story that really resonated with me. There was this, I believe, someone that Elon went to school with, or a guy that later worked at Tesla. This gentleman was buying factories, and then that were like running down, and then would automate them, and like did that multiple times and did really well with that. And that's something that I would love to do. I love manufacturing. Like that is my end goal. I love the process of taking raw material in and having a physical product come out. And someone who did that multiple times and automated the system, I find that really cool. Like I want to build factories that are not fully automated, because I love the idea of providing a good job opportunity for people. And I think building something with your hands is incredibly rewarding. But that portion of the book really inspired me, and it wasn't even about Elon. But that's what I want to pursue. It was really cool. So you had these internships. You have a piece of your own hardware floating out in outer space. Do you see the IonoCopter being something that could be in outer space at some point?
So this is another thing too that's really promising about this propulsion system, is that because the nature of ionic propulsion, the way that it works, ionic propulsion is this a big umbrella term. The way that it works is that it spits off electrons that interact with the air, and the air is then pushed. But even in the absence of air, so in the upper atmosphere, like where there's not enough air molecules, what's still happening is you're still pushing those electrons out. And so you're still getting relatively the same thrust at varying levels of the atmosphere. And this is why it's especially effective in space. Because closer to the Earth, obviously, you have the issue of gravitation, right? You have that gravity pulling you down. In space, you don't have that huge issue. And that's why a lot of satellites right now are transitioning to ionic thrusters to keep themselves in space, because it's very cheap. It's space efficient for, like, you don't need to store gas. You don't need to store nuclear materials. All you need is literally a power source, like your solar panels. And as a result, you can have a thruster mechanism that can extend the lifespan of your satellite. But in the terms of the IonoCopter, it's all. Right now, I'm really in the R&D, development phase. So any new lead, I'm definitely pursuing. There's a few contacts within Embry-Riddle that I have for like low, like atmospheric, like pressure chambers that they have that can, stimulate what it's like in the upper atmosphere, and hopefully I can test some stuff there. But that's like you said, for a later time.
That's cool. So are these chambers that are large enough that you could put it like a fully functioning copter in there? Go.
Well, the cool thing about these copters is that they're not that big.
Mhm.
Like I said, they need to be lightweight, right? And that's optimization that I'm sure I will develop, that I try to get an optimal size for. But my entire idea was to have like a quadcopter design that you'd have like on the battlefield. Um, that's you can fit in a backpack. Um, that's American made. That's not you're not relying on Chinese supply or it's yeah exactly,
No.
bro. I mean,
USA.
what? Yeah, but what it is it to have a like a drone that you're using. A lot of guys on the battlefield, that's like the warfighters, will use drones that they purchase themselves, and those drones are from China. And it's like, what use is that? It's anyway. I think the warfighter should be using American tools. You know. Besides that, I wanted to be able to fit the backpack and not have it be this thing that you're carrying around in the case because it's hypersensitive and all this stuff. So that's where I'm coming from. Hopefully I can maintain that. And hopefully this, like I said, topological orientation with how big I can make these things versus how much thrust they produce, allows me to continue to do that. But yeah, backpack size is the aim of the design.
That's exciting. Now, I'm just picturing this, and that's really cool. Would how is there a concern with like the battery system and providing enough power from a lightweight source to generate enough thrust?
So I've ran tests on what like the minimum battery voltage I could have to sustain the discharge. And I found that you can actually, especially with the smaller design, you could get the same kind of discharge off of a 2.5 volt battery. And so,
Oh, really?
yeah.
Nice.
And that was another one of those moments where you're like, holy smokes, this can actually work. But yeah, so that obviously you need the step up converter, and that's involved with the having enough even voltage to ionize air. But for your input voltage, I mean, that's great. And on top of that, you have traditional designs for how for example, like a what do you call those things? The bunny with the drums, the 2.5 volt battery. Yeah, Energizer batteries. That's what they're called. Yeah. So I mean, you can just imagine how long those last, and you can imagine the rate of discharge. It would probably last the length of how long you need for scouting.
That'd almost probably be better to just use like AA batteries in this for this application. If you're saying that if it's in a war setting, like chuck the batteries and throw some new ones in there. Is that your goal?
Exactly. Yeah. And I also wanted to make it that if you lose this thing, it's not, $500,000 is now gone,
Right.
And there's some general screaming at somebody. It's like, you just wasted so much resources. What I want is a cheap silent drone that's lightweight, that's backpack, you can carry in your backpack, that, that serves the true purpose of a scouting drone, right? Because a scouting drone that's extremely expensive, you're going to have to keep at a distance, right? Because you only have so many of those. Right. What's the point of that if you're going to have it be like person-to-person combat, urban combat, scouting? And we've seen this in the Russian-Ukraine war, right? They're using cheap drones to do for scouting for artillery pieces. I mean, and that's what I'm trying to emulate here, but for specifically silent purposes.
What's the company over in California that's doing drones? Is that Anvil?
There's
what
a
are they
couple.
called?
There's Shield AI. I know. I think it is Anvil. There's
the one that was made by the guy who developed Oculus. You know what I'm talking about?
It's on the tip of my tongue. I don't remember.
I'll look it up. They have some really cool projects. And Androl? Palmer Lucy or Lucky. Palmer Lucky is the guy. Yeah, I just watched a video on him and his organization the other day. That's some pretty cool projects that they're working on. It was interesting. He said they're like trying to build things for the government that the government doesn't know that they need yet. He's like, I hope that they want them when the time comes. Another scary thing that he shared was that China's capacity for making warships is like 200 times ours. So like, if like we lost of all of our warships and China lost all of theirs, we would make one ship and they would have 200 ships ready.
Right.
So they're kind of trying to think of like, okay, we can't build more ships, then we need a different tactic. So they're working on different types of weapons to defend against that sort of crisis. Now, to do your competition, did you have to form an LLC, or could you just go in with this idea?
You could go in with an idea. You didn't have to have an LLC yet. I'm trying to work as a sole operator right now, but I've already filed for like fictitious name registration. I'm probably either going to do a corporation or an LLC, just so I can, do patent filings and then have those patent filings be underneath the corporation as opposed to me as an individual. But yeah, that's the whole goal. And then on top of that, you can use the patent filings as business expenses and then use the business expenses as like tax write-off. It's like a whole stack thing, dude. The more I learn about this kind of sphere, the more I'm like, oh, this is how people get around this thing, huh?
It's so fun. That was a really great thing with Penn State. They offered help to file an LLC. I didn't need to do that. I already had those things in place. But then they also had what was called the Intellectual Property Suite, IP, or the IP Clinic. And so with the Penn State IP Clinic, I was able to file provisional patents with their basically students that were in school to become lawyers. So it was a great opportunity. Oh, the lady, her name was Yumi. She was so sweet. She helped me file my first provisional patent. And so it's a great experience for these law students to learn how to do these types of things. And then it provides me the opportunity to file provisional patent basically for free. I didn't have to pay any lawyer fees to do it. But I had to pay like the filing fee, which goes to the United States Patent Office. So my first provisional patent took me like 6 months to file. My second provisional patent took me about 4 hours to file. So, yeah. So after going through the whole process with like, when you get started, you have no clue. So I did it with the Penn State IP Clinic for the first time. And then once I did it with them, it was like, oh, you just fill out this document, that document, and then you upload it to this platform and you pay this fee. And now you have a patent pending for 1 year. And then there's other things where you can do an extension of the provisional patent. You get a couple more months out of that. So that was a great thing that I had access to at Penn State. So that might be nice for you to pursue some sort of IP protection, especially like if you're trying to like raise money or something. Are you looking to do another competition like this? Is there other opportunities for you to do some non-dilutive funding?
Yeah, non-dilutive funding. I got invited to the Volusia County. So the county that Embry-Riddle is in is called Volusia County. So I got invited to the Volusia County Entrepreneurship Expo, which involves a lot like the 3 other colleges that are in the area. Then because it's put on by like the city of Daytona. And what else? I also got invited to the Launch Your Venture thing, which is it's an expo that is put on by Embry-Riddle, and it's a lot more intensive. So TREP Expo was an entrepreneurship competition that was mainly focused on a pitch and also mainly focused on product. Launch Your Venture is a holistic company approach of saying, okay, what have you done so far to make sure that like this is an actual company? A lot of people for example, a lot of people in the TREP Expo in past years will just like take the money and do nothing with it. They'll just take it, put it in their bank account and just like, oh, that by the way, the whole company thing. Yeah, I'm not really interested in that at all. But Launch Your Venture is like the school being like, hey, make sure you actually have a company before you come here. So yeah, that's what I've been spending this winter break doing, is doing a lot of filing, doing a lot of like fictitious name registration. But yeah.
I experienced something like that last year. So I help out with an organization at Penn State called Nittany AI. It's an artificial intelligence group at Penn State, which I participated in as a student and competed in, and then came back as an alumni. And last year I got partnered with a team. And it was a really cool idea. They were using artificial intelligence to build this app to help people track macros and then give them food recipes on like what to eat each day, so that they could hit their target macros. And then that was based off of if they wanted to gain weight or lose weight or neutral. It was like a great idea. And they got X amount of dollars to make this MVP, this minimum viable product. And so then I started meeting with these guys like for an hour or so once a week. And it like wasn't getting done. Like the ideas were there, but there's no product getting made. And then like a couple weeks before the display of the product, they just backed out. They never made the product. So they got the money, but then they never ever delivered on it. And so I was quite disappointed because it was a cool product. I like to exercise. I try to track my protein intake. And so I was kind of vested into it, and then nothing ever came of it. So that's good that they do this due diligence to make sure that you actually pursue it. Is there funding at Embry-Riddle that you can pursue as well for research?
So
does that get kind of tricky? Because then they might get part of your IP.
Right, exactly. That is exactly right. And it's been a huge like minefield, because if you accept money from them, and I don't mean to like put the university in an antagonistic light. I am really appreciative for anything, like any research opportunities that they give us, because I'm gonna put it this way: Embry-Riddle is a university that's unparalleled in undergraduate research opportunities. Like, you don't have a freshman walk into a plasma lab and be like, "Hey, can I help?" And they're like, "Yes." Mostly, it's like, "Get out of here, punk," you know.
Yeah.
So they not only that they are like begrudging, they're like, they want you there. That's the beautiful thing. Mm-hmm. So like that's the grain of salt that needs to be added to this statement. But they will try to like take your IP, and I mean, it's just the way that it is. I mean, like, that's how universities make a lot of their money, and also how they advertise themselves, right? So I don't necessarily blame them. It's just how it is. But yeah, that's why I'm not taken a dime from the university so far, because I'm very terrified about that. Because I've been talking to some of the other people that work in the plasma lab as well about what they would used to compete in the TREP Expo. They're master students, but they did it when they're bachelors, their junior and senior year, and they were like, yeah, the minute I started taking funding from the university, I no longer had right to my IP, and I'm like, oh, I will not be doing that.
Yeah, that was something I had to consider as I was wrapping up undergraduate, was that I didn't realize if you go on to graduate school, you basically give up all of your intellectual property. And so it was like, oh, yeah, I'm not going to do that. And I didn't realize that at first. People don't really, they don't advertise that.
Yeah.
That's neat. So you have winter break now. Are you doing any product development, or right now is more of a filing, I like to call, busy work, admin stuff?
Admin stuff. That, I think it's the worst kind of work, to be honest with you. No engineering involved.
It's awful.
No, but I am doing product development. Like I said, I set up my bamboo. I'm experimenting with the radial distance, so making varying different sizes of the positive and negative ends. I was also experimenting with, actually I can go into this, it's kind of cool. Adding multiple different rings. Or so, for example, if you have like, you saw the design on my poster, where it's the outer ring with the blades. Mm-hmm. If you add multiple inner rings, the issue that happens is that you end up trapping air, because if you imagine like you're drawing lines directly from like parallel from this like bladed end up to the toroidal shape, and you add more blades on the inner ring, what you're ending up doing is you have to run it back to the same location on the toroidal shape. So what ends up happening is you're trapping air in that air pocket between the outer and now the inner. Oh. And so that air doesn't go anywhere. And what ends up happening is it ends up disrupting, because it's trying to escape. It's getting battered from electrons from every direction, and it ends up disrupting the actual discharge itself. So you end up getting is this weird popping, and it's like, it kind of looks like TV static, but it's like everywhere. And it screws with the whole thing. So we're not doing that anymore. That was a little bit of prototyping. Found out that didn't work. Can check that off my list.
Yeah, like we're not doing that. Um, Parents never come over and they're like, Andrew, what are you doing? Or they just kind of let you be. Like when this thing starts popping.
So my my parents are, my dad is like very, very supportive. My mom is very, very supportive. But they are like, please don't kill yourself. Please don't like shock yourself to death. And on top of that, I sometimes I blow a fuse.
In the house, like you'll blow a house breaker?
Yeah. Maybe sometimes. And they're not too appreciative of that. But besides that, yeah, they kind of just leave me to my own devices for better or for worse. But they do come in. They're like especially my dad. My dad's a mechanical engineer by trade, and so he comes in and he'll be like, "What's your, can you explain this to me?" And we'll just talk. But yeah, my dorm mates, like I feel so bad for my dorm, like my actual roommate he must be a superhero because he can sleep through anything. I've like done so much shocking myself, like while he's asleep. And he'll just like sit there, keep sleeping. And I'm like, sometimes I wonder if he's pretending, like there's no way you can be sleeping through this. But
like you shock yourself and you're like, ow, and he just keeps sleeping.
Yeah, he doesn't wake up. And on top of that, these things are loud too, right? Because it's ionizing air, it's crack. And you're like, oh, you look over and you're like making sure that Carson's still asleep and he's still sleeping. And you're like, huh.
He's not worried you're gonna shock him in his sleep.
I think he'd be a little more than upset if he woke up being shocked. Maybe that's the only way to wake him up.
I made this funny little video. When I'm on the computer, I'm really bad at hunching over. And I made this fictitious product. It was like it was called Straight Shock, like Straight Talk or whatever. And I put a distance sensor on the back of my chair. And then I put terminals like near my like lower body, and then if you lean forward, it started shocking my.
Oh my god!
Like lean forward, it like straight shock you. Yep. I thought that was pretty funny. Other people didn't find it as funny as I did.
What?
But that's awesome.
Awesome.
I thought it was hilarious. I made like a YouTube short on it, and like it got no traction. And I probably even hit it. But like, and I made an infomercial, like a medical thing, like try straight talk today. I thought it was so funny and kind of practical because like it would literally work because your back muscles would tense up and you wouldn't be hunched over anymore. Still in development. But that's cool that your parents are really supportive. I'm very fortunate that my parents are, my whole family. But I was over at my mother's house the other day, the friend, working on this product for him. It's an idea of his, it's an invention. It's really cool. And so we're testing it out at her farm, my mother's farm. And then we like came inside and we showed it to her and she's like, oh, that's cool. And then like started talking to me about something else. And so we left and my buddy's like, your parents aren't impressed anymore by anything you do, are they? And I was like, I mean, like, it's just normal, I suppose, whenever I like show these things to them. Like, it's not like, anything huge. It's just like what they expect. Where to him, like this invention that we made for his idea is like the greatest thing in the world right now. It's like, he can't believe that it exists. Like, he's so like, ecstatic about it. And my mom's just like, oh, that's cool.
Yeah.
But it's good to have supportive people around you. And do you listen to Alex Hormozy at all? He's more of an entrepreneurship guy.
I consider myself like a friend of mine. Like Liam Thompson is like my best friend. Me and him are such huge Hormozy buffs. Like we talk about this stuff all the time, and really like it is a philosophy of life that really is like maximizing your life as much as possible and producing as much as possible. Not just for other people, but because you are alive, I don't know. No,
he's so good. I really loved his book, $100 Million Deals and $100 Million Offers. I've read both of them. Have you read either of those?
No, not yet. Yeah. But we will. Like, I'm getting my friend Liam like a lot of both books for Christmas. Like, yeah,
they're really good books. But a cool thing with those books is $100 million and $100 million deals is very similar to dot-com secrets, which is also very similar to Tim Ferriss's book, 4 Hour Workweek. And so a lot of similarities between the three books, and some really good information. 4 Hour Workweek is one of my favorite books. I don't know if you've read it, but it's so well written, so entertaining. But Alex Hormozi is really great inspiration for people, especially in the beginning. I love he shares with the gentleman on Modern Wisdom that in the beginning, it's just like a very quiet clap. Like, you know, just one person in the auditorium, and it's two cheering on you. And that's such a great visualization, like in the beginning stages of an idea or a venture. And how by the time that like it's an auditorium full of people clapping for you, you no longer need that motivation. You don't need that catalyst. The beginning is so challenging. So I really like that. And I also, something that really has spoken to me is he shares like, in the beginning, like it can be very challenging where like you're trying to shoot for this goal, this place in life. But you're in this dark valley, this dark forest where you don't have the skills or the connections yet just to socialize with the people that are at that goal. So like you're very alone working towards that. And so that's part of why I wanted to start doing conversations like this, to be able to connect to like-minded people, and to hear hear what they're working on, and to build those relationships, because like this excites me, getting to hear what you're doing and hear your story. So I guess you could thank Alex Hormozi for this conversation in that regard, to like push me to have more conversations like this.
Yeah. Well, again, I appreciate like you coming to talk to me, because I don't know, I can't really describe. I tell people all the time, like I wanted to start a company. I wanted to, involve myself in research and all stuff. I just didn't think it would happen so quick. And that was like the thing that I keep telling people, is that I didn't think I didn't think I'd be, people asking to interview me so quick. And it is such a strange feeling, the so quick moment, because you're not really there until you realize that you're there, because it's something that you always put off in your mind. And you're like, maybe one day. And then like all of a sudden you're there, and then you have no idea what to do. And you're kind of just like, well, I guess this is my life now, and I have to like keep pushing myself. I don't know. I'm extremely appreciative. And I appreciate that there's people like you out there that actually care enough about people who win university competitions.
Oh, it's excellent. And I hope that this is an opportunity that I can share this story with other people. I am like benefactor of number one, and then hopefully other people can take the time to watch this and inspire them in whatever they're pursuing. So it's great that we have the opportunity to do something like this. And I don't know what the exact number is, but I've heard people say like bamboo grows for like 10 years underground, and you don't see a single thing. And then as soon as it does sprout above ground, it grows like 10 feet per day or something crazy like that. And so it might seem like it's been an instant realization of your dreams and your goals, but really you've been working towards this for a long time and putting in the time and effort to get to this point, and where it does grow exponentially. Like how many kids in high school have an internship where they're staying there 10 hours a day and working with the senior engineer, and they have a product in outer space? I mean, well done, dude. Well done.
Thank you so much. Thank you.
Well, Andrew, thank you so much for your time today. It's been a pleasure to speak with you. I really look forward to seeing what you build in the future and keeping up with the IonoCopter. Is there a place where you share this information online for people to just stay up to date, or is it something that you look to do in the future possibly?
Yeah. So I'm still working on socials. I'm kind of new to socials, to be completely honest with you, but I do have an Instagram. It's Murph2006. And then I also have my LinkedIn, Andrew Murphy. I'm like one of the few Andrew Murphys out there. I know there's there's too many of us, dude. There's like 200 of us on LinkedIn, but I'm out there. And yeah, those are like the two places I put stuff out for. So again, thank you so much, Jake. I really, really appreciate this.
Thank you for your time, Andrew.
I hope you enjoyed today's conversation with Andrew Murphy. I absolutely did. If you want to hear similar conversations, make sure to subscribe and stay tuned. In the meantime, be creative and go build something awesome.